Hello. So in Lab 10, in the Genetics and Probability Lab, there's going to be a couple types of math you're going to have to look at. So one of the first things I wanted to talk about is the rules of probability. Now those of you who have taken statistics, you are very familiar with most of these, I can imagine. And quite frankly, many of these are common sense. So we're going to walk through some of these and I'll talk about some of the math that you would be expected to do when given some of these problems. So, probability. In your lab book, it talks about how probability is the number of ways an event can happen divided by the total number of all of the outcomes that could happen. Now, one of the most classic examples of this, which is the one that is used in the lab book, is coin flipping. All right, so if you flip a coin, right, if you have a coin, you either have heads or tails. Okay? And everybody knows that you've got a 50% chance of getting heads and a 50% chance of getting tails, right? So the reason for that is because, your chance of rolling heads is 1 divided by the total of all the possible outcomes that are here. So 1 divided by 2 equals 0.5, or what we can call 50%. Right, so again, that's like the classic example. So the example that I'm actually going to use in this is to look at a dice. All right, so let's think about one die, a 6-sided die that you would use to play a board game. And so if we use this 6-sided die, we have 6 options, right? So what is the probability of rolling a 2 if you have a 6-sided die? Well, the probability of rolling that 2 is 1. Get this back. 1. And then you divide that by the total number of outcomes, which in this case would be 6. So your answer would be 1/6. Now, of course, you could, divide that out if you want to make that a decimal. I'm perfectly okay with leaving that as a fraction right now. So that's going to be the example I'm going to walk through with these 4 rules that you'll see in your lab book. Now, the first 2 I think of are pretty common sense things, but to lay them out as a rule, every event is independent of the one before that. So what that means is if you flip a coin, the first time it's heads. The second time you flip the coin, there's just an equal amount of a probability that the coin would again land on heads. So the event before it doesn't change what could happen. So if you roll a 2 on a dice, or on one die, then your next chance rolling the die, you have an equal number to roll a 2, right, which is 1 out of 6. So no matter what, no matter how many times you roll this dice, you end up with a probability of 1 out of 6 for that one given time. So then the second rule is that the sum of all the outcomes has to equal 1. So I called it the sum of all the things in the thing must equal 100%. So everything that's in this thing is equal to 100%. So basically what that means here is that all of the probabilities of rolling each side would equal 100%. So if you roll a 1, the chance is 1 out of 6. The chance of rolling a 2 is 1 out of 6. The chance of rolling a 3 is 1 out of 6, and a 4 is 1 out of 6, and a 5 is, you get the picture? And then a 6 is 1 out of 6. So if you add these all together, you get 6 out of 6, or what is equal to 1, or 100%, right? So this would be 1.0, or 100%. All right, so again, this is just a way, I think, for us to double check our math to make sure that we are doing our probability correctly. Now the next 2 involve a little bit more math. These are called the addition rule and the multiplication rule, respectively. So, first event. If we are asking about one event, right, that one event is going to not be determined by the one ahead of it, yes. So if we want to think about multiple different options of that event, we can add them all together. All right, so let's do an example. So what is the probability, right? So what's our probability of rolling a 2 or a 4. So if we have one dice, right, what is the chance of us in that one turn in your game that you're playing to roll a 2 or a 4? Okay, so what we can do here is think about each of the events separately and then put them together to see what that probability is. So the probability of rolling a 2 is 1 out of 6. The probability of rolling a 4 is also 1 out of 6. So if you see this or in the middle of a sentence, if we're talking about one event or another happening, then what we can do is add these two probabilities together, right? These two fractions. So that is why this is referred to as the addition rule. So if we add these together, remember your good old fraction rules, right? Adding fractions, 1 plus 1 is 2 out of 6, all right? So our chance of rolling a 2 or a 4 is 2 out of 6. Or you could simplify that to 1/3 or 33%, right? That is totally up to you. All right, so the addition rule is going to be used when we are talking about one time or one event, but we could have multiple options. Now the next one is actually looking at two events that happen at the same time or back to back. So for example, when you talk about like having children, what's the chance of having one boy and then another boy and then another boy and then another boy? All right, what's the chance of there actually being 4 boys in a row? Now yes, each event is independent of the other, right? So the chance of having one boy is 50% and another boy is 50%. But if we add all of that together, it's different, right? When we take all 4 children into account, we have to account for each event happening following the next. So this rule gets quite small, to be honest. If we start trying to think about what happens in a sequence, the probability numbers will get smaller. So let's take 2 dice. All right, so you have 2 dice. Those are going to both be 6-sided. So what is the probability of rolling what the gamblers call snake eyes? All right, so snake eyes is rolling a 1 and a 1 at the same time. So rolling a 1 and a 1 at the same time would mean you'd have to have 2 things happen at the same time. So again, we can think about these 2 as separate events, but then we're going to combine them together. So the probability of rolling 1/1 is 6. The probability of rolling another 1 is also 1 out of 6. So when we are talking about the possibility of 2 things happening at the same time, you are going to use what's called the multiplication rule. So again, if you see an and in the problem, if you're talking about 2 things happening at the exact same time, what we have to do is multiply these fractions together. All right, so that is why this is called the multiplication rule. So what you will do is you'll just multiply your fractions. Again, remember all your rules of fractions. 1 times 1 is 1. 6 times 6 is 36. You're looking at 2 things happening at the same time. Now we could keep going with this, right? We could say, what's the chance of having 4 dice and all 4 of them landing on a 1? All right, so what you would do then, so what is the chance there? Well, let's go up here. So what is our probability of rolling 4 1s at the same time, right? So rolling a 1 and a 1 and a 1 and a 1. So again, what we would do is take each individual event, right? So 1/6, 1/6, 1/6, and 1/6, and we would multiply each one of those together. So you would have 1 out of 6 times 6 times 6 times 6, which, oh my, I have no idea. So if I pull out my trusty calculator, 6 times 6 times 6 times 6. Whew, that is a very, very big number. 1, 2, 9, 6. So the probability of rolling 4 ones at the same time is 1 out of 1,296. That is a very small number, right? So the likelihood of rolling snake eyes is 1 out of 36, right? Which is a small number, but it's not that small in comparison to this. So again, to kind of think about probability here, the more times you try to compound something, the less likely it is. It could still happen, right? It's just that it becomes less and less likely. And that's part of what we're going to be applying during this lab, right? What is the probability of certain events happening, right? And how we can use that math.